Hello my dear class. Today I am going to teach you the last topic from organic section, that's macromolecules or polymers. And in this video I will explain you all the chemical reactions, types of polymerizations, their conditions, the common points, the different points and their uses. So watch full video to get the complete conceptual knowledge about the polymers. So here we begin with the definition of macromolecules. A macromolecule is a very large molecule that is made up of many small molecules. In science, the macro word is used many places, means something very large. And in chemistry, the molecule is defined as the unit of atoms which are chemically bonded. So you see, the macromolecule means a large molecule which is made up of many small molecules. As you see, this is a larger molecule which consists of further smaller molecules which are linked together. So to know more about macromolecules, we will understand how many types of macromolecules are existing. So we have two types, one natural, second is synthetic. The natural macromolecules or polymers which are found in living organisms such as DNA, natural rubber, the polysaccharides or cellulose, or the wool. But the second type, the synthetic polymers, are those macromolecules which are made by chemical reactions in lab. You know, this is the era of plastics and we have a variety of polymers which are used in daily life due to their advantages such as nylon, polyester, Teflon, epoxy and many more. Now we proceed to understand what types of chemical reactions form these polymers. Now the word polymer means, poly means many, mers means unit. So a macromolecules in which same unit is repeating itself is also called as polymer. So we have two types here, addition polymerization and condensation polymerization. Now first we will understand how come the smaller units are repeating itself for the formation of polymer. So two terms will be used in discussion. First, we will call the smaller molecules as monomers and the larger macromolecule will be called as a polymer. So we have to see that when monomers link together, it forms a long chain and this long chain is called as a polymer. Now the first type is addition polymerization. It is defined as when unsaturated monomers join together without losing any molecules or atoms, and the polymer which is formed in this case is called as addition polymers. Now these are simple words. We will apply every word on the example now. You see, this is the example of polyethylene. We have understood this equation before when we were studying the chemical reactions or chemical properties of alkenes. So you see, this is the molecule of ethene with the formula C2H4. Do you remember? Very good. Now you see the smaller molecules of ethene are having unsaturation in them. Unsaturation means there is a double bond. So this double bond is the requirement for the formation of addition polymerization, and you see all molecules are similar and they are undergoing self addition. We will call this addition as self-addition, and the product is formed, which is a long chain in which the units of ethenes are repeating themselves. So we are applying the same definition, and the longer chain is called as the polymer, and nothing is removed. We get no byproduct. So all of the molecules of the reactants are found in the molecule of the product. So nothing is removed. None of the atom is coming out. So this is called as self-addition. So the monomers are ethene and the polymers are, yes, we call it as polyethylene. The next example will also clear this situation. You see, a variety of chemicals are formed by using addition polymerization. You see, the ethene is used for the formation of polyethylene, which is used in plastic materials formation, from packaging thin films to hard plastics. It depends on the density of the product. So we have a variety of plastic products formed from polyethylene, and polyethylene is using ethene as a monomer. The next example, where the monomer is vinyl chloride. Again, you see the condition, 2 carbons with unsaturated center means a double bond in between, and when they link together they form a polymer which is called as polyvinyl chloride. Have you heard of this PVC? Yes, this is a very high quality resistant plastic which is used in making insulating materials and the pipes, and the polymer is called as polyvinyl chloride. You see the vinyl chloride unit is repeating itself. That's why the N is showing. The number of molecules are linked together, and these waves are showing that there's a bond continuing both sides. And the third type is, the monomer is tetrafluoroethene. Again, we have a double bond, and to this double bond 4 fluorine atoms are bonded, and at required condition of high temperature and pressure in the presence of catalyst, this tetrafluoroethenes links itself, the double bond opens up, and the polymer Teflon is used, which is used in making very high grade non-stick materials. Now again the same concept is used here, that the monomers, 3 monomers are shown here, tetrafluoroethene, phenylethene and chloroethene. You see, when they will be linking together, the double bond will be opened up and 2 new bonds will formed on either side, and you can write the same product like whatever is available in the reactant will be found in the product. So here you can see number of moles. If 2 moles are there, if 2 molecules are there, 2 will be linked up. If 1000 molecules are there, 1000 will be linked up to form the polymer, and this polymer is Teflon. Now this is phenylethene. You see the phenyl group, a group from benzene is attached on the double bond, which will be forming again C6H5. I told you that whatever is available in the reactant will be linked together to form the product. So here we write the polymer. Now polyvinyl chloride is again chloroethene, will be linked together to form the product, which is called as PVC. Now the same thing is shown again, the repetition of same units in the form of polymer. And why am I emphasizing on this point that the unit is repeating itself? Because the unit is carrying the same elemental ratio in the structure of the polymer. So in this kind of polymerization, addition polymers have got the same empirical ratio of elements as they were found in the monomers. So this is something which is frequently asked in the questions also. Now this is a checkpoint. The monomers are given here and you are requested to write the structure of the polymer, just to get it clear that whatever structure of monomer is available will be repeating itself in the structure of the polymer. Just pause this video here, try to write the structure of the polymer on some paper and check it out from your textbook, from your past papers. Are you able to draw them correctly or not? And the tip is, again, the double bond will be opening up and the two-side linkage will be formed. If two hydrogens are there, they will be going in the product. If chlorine is there, they will be drawn in the structure similarly. Now we come to discuss the second type of polymerization, which is termed as condensation polymerization. Condensation is a word which is normally used for the processes where water is produced. So condensation means a reaction in which the linking will be taking place and a product, water, will be produced as a byproduct. So it is defined as a polymerization when the monomers combine to form a polymer with the removal of a small molecule such as water. And two types of condensation polymers will be explained in this video, that's polyamides and polyesters. Now the main point, the main logic which is responsible for the formation of addition polymerization and condensation polymerization, that the same unit will be repeating and the linking. When we see the repetition of same units, the monomers are same, the polymer is called as addition polymerization. And in addition polymerization, the condition was having a double bond. But here the condition is difficult and different. Why? In condensation polymerization, we need one product, that is water. And it requires the combination of two functional groups, such as this is a carboxylic acid having carboxylic group COOH. And on the other hand, if it reacts with amines, the reaction will proceed the linkage in a way that OH will come out from carboxylic acid and this H will come out from amine, and the two molecules will be linked. So this is how we say this is amide linkage, and it is formed when a carboxylic acid reacts with an amine, right? So we will find such situation in the formation of condensation polymerization. Now I will come on the definition again. You see, it is defined as the monomers will combine with the removal of a small molecule such as water. This removal of water is only the condition of condensation polymerization. We will understand it with the help of example. You see, in this example, a carboxylic acid having a COOH group is shown with an amino group. These linkages are found in proteins where amino acids are linked together to form the amide linkage, you see. So this is how the OH group comes from carboxylic acid and H comes from amino group, and the byproduct is water. and this is a natural polymer protein which is found in living organisms. Now the nylon. This is the first man-made synthetic polymer. It's a thread which is used in making a variety of products, garments, packaging materials, and many more things. You see, nylon is a synthetic polymer in which the linkage is a polyamide. The basic thing to understand is the ingredients or the reacting chemicals are a dicarboxylic acid, means carboxylic acids. Di means two carboxylic acidic groups, two COOH groups are required for this. And the second starting material is a diamine having two NH2 groups in them, which are required for linking. When these two dicarboxylic acids and diamine link together, you see amide linkage is formed. Again, the condition is the removal of water molecule. So as this amide linkage will come after one another many times, that's why we are calling this as a polyamide. So nylon is a kind of polyamide in which a dicarboxylic acid is condensed together, is linked together with the diamine. So here the actual situation is the nylon is a polyamide of 1,6-diaminohexane linked together with adipic acid. So again, a diamine having two NH2 groups is linked together with two carboxylic acid fragment, adipic acid. So you see the monomers are repeating one after the other. You see this green A is representing a diamine and this yellow B is representing a dioic acid, the adipic acid pattern. So the pattern is repeating itself with same monomers A and B, A and B. They come one after the another and the linkage amide is repeating again and again because this is the linkage between monomers. So here we see the nylon is made. Another type is condensation polymerization. Here the condition is a bit different because this time we are going to study about a new functional group, that is ester. You have studied this esteric linkage beforehand, which requires a carboxylic acid and alcohol. So when these two units will be linked together, we will have COO and this. This is the ester linkage. And this reaction is called as esterification. And the other condition is also fulfilled, that the water will be produced. The OH will come out from carboxylic acid and the H will come out from the alcoholic part. So you see here hexadioic acid. Again 6 carbons with 2 carboxylic acid groups, 1 and 2, is linked together with the diol. Diol means alkane with 2 hydroxyl groups in them. So the linkage between carboxylic acid and alcohol will form the ester. This fragment is coming from dioic acid and this fragment is coming from alcoholic part. So you see the linkage is the ester one, because I am going to introduce you about a polyester which is terylene, in which a diacid is linked together with the diol to form the ester linkage. And you know, terylene is also a very useful synthetic polymer which is used in making of very quality sleeping bags and other packaging materials, because it's very stable and resistant. That is why it is used worldwide. Now we come to discuss the advantages of plastics. This is the era of technology and plastic, where plastics are on high demand because of their benefits, because of their properties, because they are relatively cheaper as compared to metal and leather, and they are easily molded into various shapes because of their lighter nature, because they are tough, they are waterproof, and they are durable. Means they are resistant to decay, rusting, and chemical attacks, because the rusting is a very big issue which is limiting us for the use of metals for the formation of structures. So the plastics are taking its place. On the other hand, we are also in trouble because of the non biodegradable nature of these plastics or synthetic fibers, because they cannot be decomposed by bacteria naturally. That's why it's a big issue these days that plastics are in use, but they are causing the pollution. They're causing pollution to air, they're causing pollution to water, they're causing pollution to our land. In fact, where when they are thrown in the sand, they produce waste materials which never undergo decomposition by bacteria, and it is a big problem. It's a big solid waste because they do not decompose, and when they are thrown in water, they endanger sea animals, they clog the river water, and whenever that is ignited or burnt in air, it produces poisonous gases. So it is a serious issue to recycle or to control the use of the plastics. So that's why uh, many countries are taking actions to control on this pollution rate, to limit the use of the plastics, or to recycle them, or to restore them. So this video lesson was enough to prepare you for the questions which are asked in exam. Just how many examples are there, how many types of monomers and polymers are discussed, you need to compare both of them. What is the condition required for the addition polymerization, and how come addition is not called as condensation, and only two types of polymers are explained in condensation types, nylon and terylene. So you go through the topic through your textbook well, and see what type of questions are there in the past papers. So if you find any difficulty, you can ask me anytime. I would love to make more videos to clear you about anything what is required to score A plus in your coming examination. Thank you very much for watching my video. Keep spreading my videos. Do share them with your friends and with other students so that they will also clear their concepts, because chemistry is all about logics. Chemistry is all about the application of this theoretical knowledge to solve our daily life issues. Thank you very much. Allah Hafiz.